Huh?
No, it's just I already have to put on a show every day anyway, right? All right, get up there and perform, Dr. H. Do chemistry for us.
Okay,
So,
are you telling me it wouldn't be the funniest thing of all time if one day you wandered into one of Dr. Tom's lectures in like mime makeup and like mocked him?
I don't need makeup to do that.
I know, but it would make it so much funnier.
But anyway, so we were making our way through the electrochemistry part here, and we eat your breakfast.
My sister was talking about this.
Guys!
You don't have to yell. It's okay. I'll get their attention in a second. But anyway, I was saying that we were making our way through electrochemistry here, and this will be kind of where we cut off the stuff for the exam then. We'll do the balancing the redox reactions there. I think it's section 10, or excuse me, not 10, 20, 20.3. Let me, can I borrow this for just a quick second? I had this, and then I forgot it. And then it came down.
We're starting in 17, section of 17.
Yeah. So 20.2 is what we'll cut it off with there. So that's what we're kind of going through right there. Okay. And then we'll pick it up from there for the final exam and stuff that we'll go through at that point.
Do you know what exact section of 17
Yeah. Yeah.
Mm-hmm. So they're 17.4.
0.4.
Mm-hmm.
Wow, this is really.
That's been spread out, right? Very. Today'd be a good day to give you guys a quiz in class. You guys are all like messed up now because the tables are different. I don't have my chair. I feel uncomfortable. But anyway, so so this will be the we'll do a couple of problems today basically. I don't know how long it'll take us, but we'll see how far we get, and then we'll continue on for the final exam after that point there. So I think that's all. I keep forgetting today's Friday, but anyway.
It feels weird because it was like half the week.
Yeah, for sure. Okay, let's get started with prayer then, and then we'll launch into it here. But Lord, we just thank you for another day, and we do just thank you for another opportunity, Lord, and just the ability just to come together and just to begin to learn a little bit more about you and the things that you've created again, Lord. We just pray that for today, you just put the things in our hearts that you want us to think about, to meditate on, and to just spend that time just with you in prayer and meditation and quiet, Lord, just learning the things that you want us to learn today. We pray that we're not distracted by the things of this world and things around us, but instead focused on the things that are important. So just keep our eyes focused on those things also, Lord, and just help us to not be distracted by everything around us. We just pray all these things in your name. Amen. All right. So, boy, we could fit you guys all around 3 tables today, right? Got that. Anyway, so we were working through this, which is balancing redox in acidic, and then the next one's going to be basic solutions. The book does it a little bit differently than what I do. You get to the same answer. It doesn't really matter which way you guys do it, right? But there's a couple different steps that you guys need to follow with. This is what it comes down to, right? So really, it comes down to understanding the steps and knowing the steps and practicing the steps and making sure that we're keeping good notes as we go through the steps. Okay, so all right. So I don't think we got any more on this problem, did we? I guess we did.
We got to. We did this stuff.
We just did part 1 then.
Yeah.
Okay. All right. So what's oxidized and what's reduced? Okay. So remember, this is one of the things that we kind of are knocking the rust off from Gen Chem 1 there. Just, what is reduction, what is oxidation, counting electrons, looking for oxidation states, following the rules to assign oxidation numbers, that kind of thing. Right? And so when you're presented with a problem like this, right, when you're, there it is. Okay, when you're presented with a problem like this, what you need to go through is take a look at what is oxidized, what is reduced, or the way the book presents it is, separate out the two different parts of the reactions that are happening, right? Which part of this reaction is working with the arsenic and which one is working with the iodine, right? So they talk about breaking apart the half reactions there, okay? So either way you guys want to think about this, it's getting to the same answer there, right? One's looking at the oxidation states and the oxidation numbers, and the other one's just saying, hey, which are the two parts that are involved with these reactions, right? That's all it is. So let's get that all kind of split apart here, right? We've got these, and we'll do red and blue, I guess, just to keep things a little bit simple, right? So there's our two half reactions. So we'll just go through and write this down. H3AsO4, right, goes to HAsO2, and I2 goes to iO3. Okay. Good? I guess we kind of took care of parts 1 and 2 here. Part 1 is what I don't know why I wrote it up there. I'm being dumb, so I'll just move it before I fumble through things. There it is. No mistakes were made. Okay. Right, part 1 is assigning your oxidation numbers is what it is. That's what I meant for that. Okay? So write the unbalanced half reactions, that's what we have. Next we need to balance all atoms except hydrogen and oxygen. Okay. So that's kind of straightforward here. So basically we're saying we need to, how many arsenics are on each side here, how many iodines are on each side here, and go through and balance that part of it, right? Piece by piece by piece. So red, okay. We got 2 iodines, only 1 iodine over here, so we just need to come in and I did the same thing. Duplicate. There it is. Okay. Balance the atoms except for hydrogen and oxygen. So take care of how many iodines and how many arsenics are on either side there. I'll let you guys kind of follow along from here. Take a look at oxygen from both sides. Add H pluses as needed, and then balance the charges here. So see what you guys can get through. We walk through our steps.
Do we usually say half reactions or?
Each step is building off the last one, is what it is, right? So your take for part 4, you're building off of what you did in part 3 there.
Okay.
So we're writing like the full equation.
Yeah, we're getting to that at the end, yeah. We're just balancing each half for it first.
But it says add H2O is needed?
Mm-hmm.
I'm confused.
About what?
Are we adding H2O to one of the half reactions?
So you need to balance the oxygens, right? So if you take a look at the one in blue, right? One side has 4 oxygens, the other one has 2.
Right.
So we need to add 2 waters so that each side has 4 oxygens on it.
Right. So we're just adding water to that half reaction. Okay.
Yep. Well, so you have to do it to both of them, right? Because both of them don't have balanced oxygens. Right? 4 originally, 2 originally. Man, I don't know. It's gonna be a long day. All right, there we go. Okay. 4 here, 2 here, 2 oxygens here, balance our total oxygens there. But
Oh, you're balancing the oxygen here.
yep, so balance oxygens, and then we're gonna balance the next one, right?
Okay, okay,
We're doing step at a time, right? So 6 oxygens, 6 oxygens, right? Yeah, probably a little bit different, right? But it's not quite the same balancing as what we're used to with overall reactions, right? So, a little bit different. So now that we added oxygen, or we took care of the oxygens on both sides, now we need to come back and take care of the hydrogens, okay? And there's gonna be a subtle difference in step 5 here for how we deal with basic versus acidic conditions, okay? We'll come back and I'll kind of mention that a little bit as we go through it, but there's gonna be one of the points of differences between the two. So we have 3 here, 5 hydrogens on that side. So what we'll do is come back, add a couple of H pluses here. Okay. Here we have 12 hydrogens on one side, so we need to add 12 hydrogens to the other. Oops, I wrote 11. Good. Now we need to go through and balance the charges. We have to make sure that the charges on each side are equal to each other. So if you take a look at the half reaction there in blue, take a look at the half reaction in blue, like one side has a +2 charge there from the hydrogens, right? And the other side is neutral, right? So we need to make sure that both sides are neutral, right? So we're gonna add 2 electrons to the left-hand side there to get that to neutral. Okay. If we take a look at the stuff with the iodine there, we've got a 2- charge and a +12 charge. So overall, we've got a +10 on one side, right, and a neutral on the other. So we gotta come back here then. Let me give myself some space. H2O. Minus, +12, H plus, +10 electrons. And this is really where it all comes up to. All the steps before this are just to see how many electrons are on each side of the equations that we need to add together. Because that's where we're actually going to come in balance. Got it? So we have 10 electrons over here, right? We have 2 electrons over here, so we need to multiply or divide or whatever we need to do to get an equal number of electrons, and then we can add the 2 halves together is what it is. You guys with me on that one?
So wouldn't the quickest thing just be to multiply the top one by 5?
Yeah, that's what we'll end up doing, yeah. Cool, so let's go through, and we'll do that. And I'll do that instead, okay. Let me scroll like this, and we'll give you guys a chance to copy that if you need to. Okay, so we're gonna take our arsenic stuff. I'll do this in green, just to let you guys see, right? We're gonna take that and multiply it by 5 so that we balance the electrons there, okay? So this is going to then make 5H3AsO4, right? Plus 10H plus 10E minus, right? So we're adding, right? We're adding our equations together. So we'll bring in this stuff here, right? Plus, we didn't do anything to that equation, so I2, 6H2O, okay? Added the other side here, 5HAsO2 plus 10H2O.
10H2O?
Mm-hmm. From here,
Oh,
from here.
okay, I see.
And plus, let's see, 2IO3, 1 minus, plus 12H plus 10E minus. Goodness.
Wait, sorry, what are we doing this step?
We just equalize the number of electrons, right, from the step before, and we just added the two equations together, right? So I took the stuff that's on the left side of the arrows, right, and the right side of the arrows and put them together as one equation. Because remember, the first step is we split them apart, right, to equalize to balance the individual stuff, and now we're bringing it back together. What's up?
That makes sense to me. How about the electrons? I don't understand how you did that.
Understand how I did, which part?
How you added in 10E on the reactant side of the red, or how you added in 2E in the blue. Like, where did that come from?
From the step before here, right?
Yeah.
So we need to balance the charges on each side there is what it is, right?
So is out of each atom, did you take the electrons?
So your question is where do the electrons come from?
Yeah.
Yeah. So if you go back to step 1 where you ask, hey, what's being reduced or what's oxidized, right? That'll tell us how many of each of the atoms gain or lose electrons is what it is.
I see. Okay.
I was gonna say something else here, I forgot. But anyway. Okay, so now I think it's on the next slide for you guys. Right, so I'll just scroll down here for just a second. So to kind of finish things up, we just need to this should really say clean everything up here is what it is, right? So we have a couple of things to think about, okay? This is gonna be another one of these important parts when you're dealing with acidic versus basic balancing of these redox reactions, okay? You're gonna make H3O plus, right? So we're gonna add the H pluses and the H2Os and all these kind of things, and that will make acidic conditions is what it is, right? Remember, when you have an acid, it dissociates into H3O plus or H plus in water is what it is, okay? We can add water if we need to, but remember at this point, we've brought everything back together. So if we add water to one side, you have to add water to the other, is what it is also, okay? But we can also start to cancel things out, right? So it's just like a mathematical equation at this point. If you guys notice, I've got 10 electrons on either side of the equation, right? So what does that mean? Yeah, we can just remove them, right? They're on both sides of the equation here. Right, they'll just cancel out, okay? And you can even start to do that with the waters and things also, right? We have 6 waters on one side, 10 on the other, right? We got some H pluses on either side there, all these kind of things, right? So we can start to kind of clean this up a little bit. let's go through and finish up with our cleaned equation then. So at the end of the day, what I got was 5H3ASO4 plus I2 goes to make 5HASO2 plus 2H2O plus 2IO3 minus plus 2H3O plus.
Why did
We.
2H2O?
Cause we canceled most of the H2O, but not all.
Shouldn't it be 4?
See, did I
Yeah, it should be.
typo something here?
But I think some of it combined with the H.
Oh, that, yeah, so the, right, yeah, you're right, 4 originally, but we combined it with 2 of the H pluses in there to make our H3O plus.
Okay.
Now, let me give you one other point of distinction from the textbook here. The textbook actually kind of stops and just leaves things at H plus, okay? So, I don't care if you guys wanna do it that way either, right? You're like, that sounds easier to me, I'll just stop there. I'm okay with that, right? I'm okay with that. The only point being this, right? Remember, there's no such thing as just H plus floating around in solution either, right? We have H plus bound with water, we're under acidic aqueous conditions. So technically, there's no such H plus, but I think we all understand that at this point, right? So if we want to kind of bypass some of this, I'm all right with that too, okay? You guys look like you're having fun. How was that, huh? What's up?
On a couple steps before, when you multiplied the first one by 5,
Yep.
was that just to get the electrons
Correct.
the same?
Correct. Yeah, that's the key step. We were doing everything else before that. The way we really balance things is by looking at the electrons that are transferred,
Okay.
right? Good? All right, let's do another problem here then, just to kind of walk through the steps one more time. So let me switch over to a empty paper. Let's see, that's organic. That looks like stuff for you guys. Okay. This one, let's see.
What is, don't.
Huh?
Nothing.
Okay. So we have, whoops. CR2O7, 2 minus, Cl minus, CR3 plus, a Cl2 under acidic conditions. Okay. So a typical question is balance of following redox reaction, and they'll tell you either acidic or basic conditions, okay? So this one's no different than what we just did, just, you know, the individual reactions there are different, you know, have different atoms as part of it, right? So see what you guys come up with. Let me help you guys out here. And step 1, right?
Oops, sorry.
What is oxidized or reduced? Okay. Step 2, right? Right, your unbalanced half reactions. There we go. Okay. There's your 7 steps. Figure out what's oxidized and reduced, separate out your half reactions, balance, 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 and then bring them back together. Okay? So see what you guys come up with. Hmm. Hmm. What do you mean?
It's only on the reactant side, the oxygen.
Because we're looking at individual atoms for the redox.
Yeah, look at what happens to the chromium, right?
Yeah, that's what I did too. Hey Doc, is O usually -1 or -2?
Yeah, I think you're.
Oxygen is usually 2 minus.
CO207, is that peroxide or?
No, that's a dichromate is what it is. So yeah, it's not a special case of oxygen or anything like that.
What does peroxide look like?
It'd be something like H2O2, right? Okay, so let me answer that question a different way. It's tough to sometimes tell what a peroxide is without like having the name of the structure in front of you, right?
Okay.
So that's not one of these things that I would, that's not one of these things that I would hide from you guys, right? If you have something like H2O2, you don't have to know it's a peroxide to know the redox because of the rules and the way it works. But that's a good question. Actually, ask me that in a little bit, and
Okay.
I'll walk through that with you guys.
Alright.
But here, don't assume that I'm trying to trick you.
Okay.
I see that from you. See. That was what first. The whole thing? Yeah, that's what the question's asking. Right? And I'm telling you how to do that with those 7 steps. Yeah.
Okay, so go ahead and get the oxygen.
So you can see what oxide is reduced, right, and then you separate out the 2 half reactions, right? Where's the chromium involved, and where's the chlorine involved, right? Yeah. There is no O, so you don't need that one. Yeah. Correct. If there's no hydrogen, then you don't have to worry about that either. But be careful, if you add water, you have to balance the hydrogens, right? So.
Yeah, okay, yeah, you're right, sorry, I'm so brain dead. Always get them. You're fine, I'm just brain dead.
So remember, as you're not just adding O, you're adding H2O. Like you add water to balance the oxygen, right? There you go. And then you have to come back and balance the hydrogen there for that one.
When I balance electrons, so there's 3, and there's 4 more electrons on this side. This is reduced, right? Go from +7 to +3.
Okay.
Oh, okay, what other stuff?
This is a
this is 0.
Right,
Yeah, so you're just looking
Yeah.
at what where the
Right.
chromium is
Try to balance
involved and
electrons,
then
you're
where
not looking
chloramine is
at
involved.
the
Right, those are the two
oxidation
half
numbers.
reactants.
I'm just
Right.
looking at the charge.
The charge of the atom.
Yeah.
Yeah, so this
So
is
basically
zero.
just splitting
This
apart
one's
the
0.
individual
This is
components
3.
that are in there, right?
Like it's not, does not have to do with that.
Oh.
You just use the oxidation numbers to get that. So like make sure you're getting.
That should be
that's what
balanced
these ones-
previously.
Like with electrons?
Oh, what's separate? Oh, the balancing electrons, oh, sorry.
On the same side.
What's on the same side?
Wait.
Like if I add the electrons, I don't have any reaction on the product side. So
Hmm,
it just messes me up.
maybe, yeah. Cause yeah, you should have 2 electrons over here, right, to balance out the 2 minus charge there, right?
Oh, I see.
Oh, this helps. I do not do that, but how do you do it on this side?
Because this is 14 plus and then 2 minus, so then you need this, the whole charge is 12 plus, and so make it much more than 12 electrons.
I just saw it as one.
Okay.
Yeah, I just saw it as like 1 plus.
Yeah, your electrons shouldn't end up on the same side.
Like they never will.
Yeah, no, right,
Okay. I
otherwise
was
those
like,
things
that is
can't
not right.
cancel out, right, so.
Okay.
I mean, if you do that, that'd be great, cause then you just created matter.
Oh.
And then I'll give you 5 bonus points on your final grade.
To the left side.
So I'm adding.
For which side? For which one are you
So if
talking
I'm
about?
trying to interrupt these 3 pluses because they're going to the active side.
Because there's
positive side.
2 chromium 2 pluses, right?
Whatever side needs to be more negative.
Oh, on the right
So
side?
something needs to be over there.
Yeah, I haven't done it. I didn't do that.
Oh, okay.
Help me out here. You show me what you did.
Wait, I'm trying to figure it out because I messed it up. I did this wrong. Okay, one second.
Okay, so you added your water and your hydrogens.
Yeah.
Do you want them ultimately to be neutral?
Okay.
Everything needs to balance at the end.
I'm gonna have to balance the hydrogen.
Yes, and then add some.
So if you have a +1 on one side, it needs to be +1 on the other side also.
Oh, so not necessarily, don't necessarily have to make things neutral.
No. Like I said, it's really the electrons that we're balancing. The assumption that's made, right, and this is a good point, the assumption that made is that we have enough water and counter ions and all these things around, right? Because if you take a look at even where we started, you can't just have Cr2O7 2 minus, right? So there's probably some sodium floating around, right? So we're just simplifying this a little bit by taking out spectator ions and these kind of things. In reality, yes, everything has to be neutral, right? But, well, you're not gonna have to add electrons to both sides, right? I mean, you can, and then it will come out later, but really you just need both sides to be an equal charge. So you're not, it's not necessarily wrong, but you're kind of adding something that you don't need to either there.
Okay, I follow.
So like this
Mhm.
is
Yeah.
12 plus.
Yes.
So this side you can to what? To, you know what I mean?
Yeah. So yeah, this one's 12 plus. And what is 12 plus?
What then would you add electrons? So what does that age? Do you know what I mean? Like do you think like since this is 6 plus, should we just get this down to 6 plus so that it's 6 plus on both sides?
No, you can't.
Cause like this side.
Oh yeah, you're not
No.
gonna have electric on both sides.
Or how do you?
Like you would just add. This wasn't that side. It's the same thing.
Right.
Like adding like.
So then the charge is like 6 plus on both sides?
Yeah.
Okay.
Okay, so step 1 is taking a look at, what gets reduced and what gets oxidized, right? So, I went ahead and just split up the individual parts here.
Okay.
Well, we see chromium starts with a +6 and goes to a +3, right? Chlorine goes from a -1 to a 0. Everybody with me on that? Why is that important to look at? Why do I add that step in when the book doesn't really?
hold on. It's 6, not 7?
Yeah, each one has to have a +6. Oxygen, total
Oh,
of 14,
okay.
there,
I'm
that's
an,
it.
yeah, no, I'm an idiot.
Yeah, don't forget the 2 minus
I
marks
can't
there,
do
yeah.
basic math.
That's okay, that's okay. What is happening to the chromium in this reaction? It's being reduced, which means what's happening to it? It's getting electrons added to it, got it? Right? And then the chlorine has electrons removed from it, okay? So this goes, I saw somebody goes like, wait a minute, my electrons are on the same side, they're not, right? So be careful about where you add your electrons, right? This basically tells us one side is gonna have things added, the other's gonna have it removed, right? So this is something important to kind of pay attention to about where your electrons can go when you balance things. It's a good way to kind of go back and check to make sure that you see what's going on with this, right? Okay. So, but, let's see, so step 1, step 2 was separate your, write your unbalanced half reactions. Okay. And then we need to go through and balance things here. Not the oxygen, not the hydrogen, so we have 2 chromiums, 1 chromium, 2 chlorines, right, 1 chlorine, so we're just gonna go through and balance that there. I believe that's step 3 for us, right? Yeah. So step 3, balance. So we have C every time. Cr2O7, 2 minus, goes to 2, Cr3 plus. And here we have 2 Cl1 minus, goes to Cl2. Good, right? I'm gonna kind of just work through the next couple steps here, but please stop me if you guys have a question or something comes up there. So now we're balancing the oxygens. So we have 7 oxygens on this side. So we are going to add 7 waters over here. Okay. Here we don't have to worry about it. No oxygens there, so that makes that balancing a little bit easier. Now that we've added water, we need to balance our hydrogens. So we have 14 hydrogens here that we need to add. Plus Cr2O7, 2 minus. This is still all the same. Okay. Then we get to the most important part here, which is balancing our charges, right? So, what do we got here? So over here we have a total of plus 12, right? And here we've got a total of plus 6, right? So we need to add electrons to one side to make it equal to the plus 6 on the other there, right? You guys with me on that?
Mm-hmm.
So this is the first kind of real tricky part. Just paying attention to which side we need to add the electrons to, right? So 6 E minus plus 14 H plus Cr2O7 2 minus 2 Cr3 plus 7H2O. Okay. Chlorine over here is a little bit easier, right? We just have a 2 minus on one side, so we're just going to add electrons on the other side here for 2 electrons there. Everybody still with me?
Mm-hmm.
Right? And here would be a first place to check. Electrons on the left-hand side, electrons on the right-hand side, right? And then go back and take a look at what happened with your oxidation and your reduction at the beginning in step 1 there. We said, hey, what's going on with the individual parts here? One thing has to get electrons added, the other one has to lose electrons along the way. Okay? Cool. Step 7, balance the electrons. So I'll do this in green real quick, right? We got 6 electrons here. Oops, we got 6 electrons here, right? 2 electrons here. So I believe I just multiplied that by 3. right? And then we just started to add everything together, right? So let's do that. Red. So 6 electrons plus 14 H plus CR2O7 2 minus plus 6Cl 1 minus 2Cr 3 plus 7 H2O, right? Plus 3 Cl2 plus 6E minus. Good? I'm not just stopping for effect, I'm double checking my work. It's so easy to make a clerical error when you guys are going through this stuff here also. So 6 from there, 2 CR, 7, 3, yeah. Okay, that looks like I got everything with us, yeah. Good, okay, now we can cancel some stuff out. Everybody have what they need from this before I erase things on the same side there?
Yeah.
Can you explain what happened with the H pluses?
What happened with them?
Yeah.
We're balancing the waters, right? So remember, at the end of the day, we have to have the same atoms on both sides, right? Right, so we have 14 hydrogens here because we have 7 waters over here, right? So that's where the hydrogens came in.
Oh, I see.
So we have 6, we can erase the electrons because those are the things that are balanced. And I think this is the answer that the book leaves it in right here, which is just fine, okay? If you guys wanted to, add the waters and make the H3O pluses and all those kind of things here and there, that's fine too. Let's see, last point to double check. Let's see, we've got 6 minus, right? 8 minus, 14 plus. So that's a total of 6 plus over here, and a total of 6 plus over there, right? Yeah.
So on the test, do you care if we leave it like that?
No, that's fine. I'm just showing you what I learned, and I'm showing you what the book, but either way gets you to the same answer, right? So, yeah.
What would it look like if you were to simplify it with the H plus and the water?
You would basically just turn the 14, you would have to add water over here, right, to turn this into the H3O plus, and then you have to add it to this side over here,
Okay.
right? Because now we brought everything back together. So if I add water here, I have to add it to this side over there again. That's all it is. Good? What's the secret to these problems?
Practice.
And crime, right? Right? It really just comes down to being deliberate with each step that you guys are going to take, right? And again, it's not just for show that you see me rewrite the equation each step along the way. It's so that I am caring and doing everything deliberately and stepwise. The only mistake that you guys can do here, right? The only mistake that can really happen is if you guys try to skip steps, okay? And that's where things go wrong. I don't know a shortcut to any of this stuff. There might be something out there and you're gonna watch some YouTube videos like, hey, all you gotta do is these 2 steps. I'm like, crap, why didn't I think of that, right? Okay, but I've never seen anything like that. So just go through, find whatever steps you guys need, but stick to that path is what it is, okay? Good. Okay. So we're gonna switch back over to the notes. Not those. Those. Okay. But wait, there's more.
Oh no!
Right? So now, right, we've learned how to do everything with acidic conditions. Okay? But unfortunately in life, there's things called basic conditions also. Okay? So now this one should be all worked out in the notes already there, so you guys can print that out and take a look at it. But let's say we got to balance this reaction under basic conditions, okay? And what you'll notice is that we take the exact same steps, okay? And at the end, we're going to change something up, and we'll show you guys there. Now, the book and I differ a lot more when it comes to balancing the basic conditions here, okay? The book tries to add 2 of these steps together. I don't see a real purpose in that. It just kind of confuses me as I go through it. But again, I don't care, right? Either way that you guys want to do it is fine, right? I just prefer to remember one method and then say, hey, am I under acidic or basic conditions? Okay, and I'll show you guys that exact point where you have to answer that question, all right? So I find what's oxidizing, what's reduced. I balance the half reactions. I balance my the individual atoms in here, although right, nothing to do in this case. Okay. Kind of zoom out so that if you guys aren't copying this down. I balance my oxygens, I balance my hydrogens, I balance my charges, right? So those are our steps. Balance the atoms, balance the oxygens, balance the hydrogens, then balance the electrons is what it is.
So it's the same as what we just did.
Everything's the same so far, right?
So what's the difference?
I'll show you guys in just a second. The difference comes from this, okay? How much H plus is there under acidic conditions?
Lots.
Yeah, well, I guess that's a fair question too, right? Lots, everywhere, right? There's infinite of it, so to speak, right? How much is there under basic conditions? Very, very, very little, okay? They're like, hey, then why are we using H plus to balance it? Don't worry, we'll fix this problem in just a minute, okay? Right? So this is what we're gonna have to pay attention to, okay?
Is it because O is -2, so H plus just binds to O and ends up OH minus?
Kind of, but we're gonna deal with it by adding OHs to make waters is what it is. Right, I'll show you guys in a second, no more, okay? So far everything the same, right?
Why don't we just add OH in one step?
That's what the book does. And you guys can do, they add H pluses and OHs at the same time, right? Like I said, there's nothing wrong with doing that, it's just,
Couldn't you just do, never mind.
right? So steps 6, did I skip a step? Oh, there's another typo, that's something that I never do. Okay, anyway. Numbering of multiple questions, 10 on your exam. Okay, so we found another typo, great.
Which question 10? There's multiple questions.
So again, we get to the point where we balance the number of electrons, and that's how we, right, balance the two halves and bring it back together, okay? So still nothing different, right? Still our electrons cancel out, but now this is where it becomes important to ask, are we under acidic or basic conditions, okay? After we've brought everything back together, we cannot have H pluses under basic conditions. So what we do is we add OH minuses to turn the H pluses into waters. Got it? So if I have 4 H pluses, I need to add 4 OH minuses. But remember, now that everything's back together, if I have 4 OHs here, I need to add 4 OHs to the other side there, okay? This is the key part about whether it's acidic or basic. Whether you add OH at the end or you don't, okay? Everything else is the same.
So it's just one extra step.
Yeah, essentially.
Okay, that's not too bad.
No,
I
I mean, it still sucks getting to that point, right? The only difference is adding OH at the end or not.
What the heck was that?
Some screws fell loose?
Projectile ones.
No.
So is ever H2O added?
Projectile pen.
Hmm?
Is water ever added?
Yeah, so remember when you balance your oxygens and hydrogens?
Yeah.
It's not in the example I picked here, right? But the same thing is what we did under acidic conditions. You add water to balance hydrogens and oxygens there. Okay? Alright, so here's the big key thing to highlight under basic. We add OHs to get rid of our H pluses, to turn them into water, right? Not to cancel them out, they just get turned into water is what it is. Good? So I'll ask you guys a question then. So, do you want to work through another practice problem with the basic conditions? Or do you guys want to end class a little bit early?
Both.
Both. I don't think that's how this
I
works.
want to instantaneously
Yeah.
work through a basic problem and then
Another
get
practice.
Let's practice.
Do a practice problem? Okay. That's good. I didn't have one prepared, so I was hoping you guys say, let's go home. No, I'm just kidding. Okay. I gotta make something up on the fly. Okay. So here we go. There's no way I could make one of these up.
I bet you could. bet if you really need, like, if your life was in danger, Doc, I bet you could make that work.
I don't know. Okay, so let's balance this under basic conditions, right?
So will you like always say if it's basic or?
Yeah, oh yeah. Yeah, I have to give you some information about that.
You said, oh, yeah, you.
Yeah, under basic conditions, yeah.
You good?
Thank you.
Is it? Is that CN or CN?
Yeah. Your
What?
conversation.
Cause you.
Oh, yeah, so I did, so yeah, I guess I need it. This is one of the habits of writing in all capitals.
My dad does that too and it drives me freaking nuts.
You guys can't read my mind. So this is, right, that's manganese, and then the other one's cyanide is what it is.
That's the only way my writing is legible.
Oh, that's my, yeah, like writing in capitals slows down my writing, and so then you guys can actually read it, otherwise it's, I got bad handwriting otherwise. So see if you guys can walk through this one.
So, Doc, I have a very important question for you.
Oh.
Did your handwriting magically get bad when you got your PhD?
No, I was always kind of bad.
Okay.
Yeah. That's how I knew I was gonna be a doctor though, right? I'm just kidding. I'm kidding.
That's hysterically funny to me.
Separate out your half reactions. Balance the atoms.
Would manganese,
Oh,
would, is that gonna be a metal,
Oh, I was putting them together.
Yeah,
metal oxygen, is there a rule?
do you know
I
that?
thought that was metal plates. And
Yeah, no, this isn't anything special going on.
Okay,
here.
so
Yeah.
O is still two,
Iron
Yes.
charge?
okay.
Yeah. Yeah, no peroxides, that kind of stuff.
No. There has to be a known.
Ah, so looking at the CN versus the CNO there, yeah, this is a little bit tricky about this one there, right? So how can we get to that charge there?
Well,
So don't, yeah, that's a fair point. This is the one thing I didn't like about this example. But actually, it's a good teaching point here. I'll bring it back together. So what is going on, right? So remember we're dealing with redox chemistry here, right? Reductions and oxidations. Why do we call these things reductions and oxidations to begin with? Well, the term oxidation originally meant whether or not you're adding oxygen to things, right? I'm just telling you, right? That's what it originally meant, okay? And so the opposite of an oxidation is a reduction, so you're removing oxygens from things. That was what they thought originally was going on with these reactions. So if you think about it, what's going on with the CN minus to the CNO? Well, we're adding an oxygen, right? So that's the thing that gets oxidized, and what happens to the manganese? We're taking oxygens away, so that's the thing that gets reduced, okay? So, in fact, that's the way we're gonna approach things when we learn about oxidations and reductions in organic chemistry, okay? So we don't have to worry about some of the more complex things there. Because the question is, how do we know what the oxidation state of the carbon versus the nitrogen is in there, right? So that's the tricky part of this, okay? But you guys are all good. We can just assume that we don't need to know that in this case then, if that's what you guys wanna think about.
You just like look at them together.
Yeah, that's fine, yep.
we can just say CN is oxidized.
Yeah, that's fair.
We'll just look at it now.
Oh.
It'll end up being the carbon that's actually changes from +2 to +4, that's what it is.
isn't nitrogen more electronegative?
Yeah, that's why it has a minus and the carbon has a plus.
Oh, gotcha.
What's that?
How is CN oxidized?
is the oxygen added to CNO on the other side? That part oxidized and then MnO4 reduced.
Wait, why is MnO4 reduced?
That's just how this reaction.
My brain is so freaking dead.
I think it's from a 7 to a 2.
Well, to a 4, right?
Oh,
Yeah.
frick me. I cannot nap today.
Okay. It's Friday. You guys are allowed 2 mistakes today. I'm gonna start working through this stuff here, but you guys can carry on.
It will take me probably 5 times longer.
That's okay.
When everything's happening together.
Big freaking
You have extra
group right
resources.
now.
Probably can.
Why are we doing this to ourselves now that we could be English majors or some stupid crap that doesn't require brains?
Not very
They're
nice.
so harsh. Okay, like not this kind of braining though, you know what I mean? Like this is a different type of braining that we're willfully subjecting ourselves to. It would be fun if I was not brain dead. Oh my gosh, I did the NN too.
These are always the best YouTube videos. It's just like 20 minutes of me being quiet. skip.
Third step.
Okay. Remember, step 5 is where we unbalance the electrons, and then step 6 is where we bring everything back together, right?
Okay, so step 2 doesn't exist because that would normally be adding
Well,
hydrogen.
Well, no, step 2 was just balancing the reactions, right, for the individual atoms that
But
are
they're
in
already balanced.
Yeah, so the carbon and nitrogen is balanced, the manganese is balanced, so we don't have to do anything for that, is what it is.
And then step 3, we're adding.
Step 3 is balance the oxygen, step 4 is balance the hydrogens, step 5 is balance the charges. right?
Okay, because we add oxygen by adding water.
Yep.
Okay.
Good,
What
so I
about-
think that's the end of class, but step 6 is you guys balance the electrons, bring them together, right? And then step 7 is where you add the OH minuses to get rid of the H pluses. Okay?
Why did you add 2 electrons instead of 5 on the left side?
Why did I add 2 electrons?
Wait, I did that wrong.
Oh, here?
Plus 1.
So here was -1, right? So I just needed to count out the H pluses that I added, basically, for this, right? Yeah.
So we wanna get 6.
Mhm.
And you're fine with this is with H plus, you don't.
Not in, you can't do that under basic, right?
So if we have
H plus doesn't exist under basic.
But in general,
Yes.
like the acidic ones.
That's fine, yeah.
Add it before
Mhm.
you add them together after. I mean, like, did you put the reactions together? And
Can
then
you show us how to do it though again?
Then you just add both sides.
How to do what, I'm sorry?
This class, putting them together to.
Yeah, I'll show you guys that at the, yeah. But let me give you guys the answer, just in case you guys wanna try and work through it on your own. So at the end, I get 3CN1 minus plus H2O plus 2MnO4 1 minus 3CnO 1 minus 2MnO4 plus 2OH minus. Double check here. 3 minus 5 minus 3 minus 5 minus. Looks good. Okay. Cool. Like I said, we'll do the next two. We'll do the last two steps next time on Monday there, and then we'll carry on to the next part: how to build a battery. No, it's fun actually. Cool. Okay. I'll see you guys on Monday then.
Is this as far as our exam?
Yes. Yep. This is section.